So in this video we'll be focused on the formulas related to the volume of complex 3D shapes. So not only will we be going through how to remember and revise the key formulas, but also looking at the more commonly asked questions that you will get asked in exams, tests or in homework or classwork. So finding the volumes of cubes, cuboids, cylinders and all types of prisms, there is a set method behind each formula, and that method is the formula you can see near the bottom, and that is that the volume of any prism is the cross-sectional area times the length. Now, one of the key things in maths that people tend to find more difficult is the amount of formulas that you need to remember. And yes, that is a sad truth that you do need to remember quite a lot of formulas, but what makes that process easier is if you understand where the formulas are coming from, and if you can find shortcuts and sort of little smart things you can find to help you remember such formulas. So sometimes they're mnemonics, in which little rhymes and little songs you can remember that are plenty on YouTube that you can find, but also generally find that the basic concepts. Now, as it mentioned then on the formula, the basic concept of the volume of any prism is that it's the cross-sectional area. So if you pick a face that is on the shape that is repeated that makes that shape, so for example on a cuboid it is the square, on a cuboid it is one of the rectangles or one of the faces, one of the three faces I should say. On a cylinder it's the circle, and on a triangular prism it's the triangle. So again, from that, if you can then think of, right, okay, well the volume is the cross-sectional area, which in this case is the square, which is worked out by L times L, and then we multiply that by the length or the depth or the width or whatever you want to call it, so that then becomes L cubed. For a cuboid, again, it's the area of what I've highlighted, so that's going to be AB times the length, which is C, which gives us the formula of ABC. And here for a cylinder, if I work out the area of the circle, so that's pi r squared, and I times that by the height or the length or whatever you want to call it, and there you go. So you can see how this formula does work. And finally, for a triangular prism, if I work out the area of the triangle first, that's base times height divided by 2, and I times that by the length, and there you go, you've got your four formulas of those four basic shapes. So as I said, it's always important you understand where these formulas do derive from. So let's have a look at the next step. So, however, there are some common 3D shapes that aren't prisms and that have their own unique formulas that you must learn and remember. So the first one is a sphere, and here the formula is V equals 4/3 times pi r cubed. A pyramid, so this could be a square-based pyramid or a triangular-based pyramid or a hexagonal pyramid, but basically the general formula is V equals 1/3 base area, so whatever the base is, whether it be a square, a triangle or whatever, times the height. And then finally for a cone, again we've got V equals 1/3, and then we've got the base. So if you think like a pyramid and a cone, they look very, very similar, it's just the base that's a different shape. You can see here that this part here is actual base area, which is a circle, and the area of a circle is pi r squared. So the formulas between a pyramid and a cone, there is a set sort of format in which you can, it's just 1/3 times h times the base area. Now the key thing to note when you're dealing with volume is you're needing to multiply always three letters or three variables together is what we call it. So here you can see your three variables are r cubes, that's r times r times r. For the base area, for a pyramid rather, we've got one length which is the height, the other is the width, and that's both how we calculate the base area, and then our third variable is the height. And likewise for the cone, we've got two variables in the radius squared and one variable in the h, so therefore we've got our three. So when we're dealing with volume, we're always multiplying three sort of unknowns or variables together. Now there are a next stage of notable 3D shapes that you kind of need to be aware of, and again there's certain ways in which you can remember how to remember these particular formulas. So a hemisphere is basically half of a sphere. Now obviously you can try and remember this formula, and these formulas generally won't be given to you. Now this formula is derived from the previous form of a sphere, which was V equals 4/3 pi r cubed divided by 2. Now if you then go on to simplify that, that then becomes V equals 4 over 6 pi r cubed, and also we can simplify that fraction so it becomes 2/3, and there we have got our formula. So yes, it's all good well if you can remember the formula for a hemisphere, but if you remember the formula for a sphere, all you then need to do is divide by 2 and you'll get to the formula again. Now at a much higher level we've come to Frustums. Now this is basically where you have chopped either a pyramid or a cone into 2 sections, and it's the bottom section that you're dealing with. Now depending on how you're taught or what revision guide or what website you go on, there are different variations of different formulas that you can be given. Now as I said, there is a key link between a pyramid and a cone, so you can expect to find some similarities in the formulas of each, and like I said, depending on how you prefer or remembering these formulas or what type of formula will depend on whichever suits you. So again, looking at this, so here we've got v equals 1/3 and then h, so that's again appears in both. And then we've got b squared. Now in this particular formula, b is just the length of the base. So that's this length here. So it's not the area, it's just the length. And a is the length of the top. Now if I just pick a better colour than that, because that one's not the best to see. Let's go for this purple. So that there is a, and b is this length here. And obviously when we move on to the cone frustrum, here we've got r is the radius of the top circle, and capital R is the radius of the base circle. And then obviously we've got the formulas here. So as you can see, there is very strong sort of links between the two. If you look at the brackets, you can see that r with just basically the brackets are exactly the same. So b squared is the bottom one length, and again the bottom radius here when dealing with circles. A is the top, related to the top shape, which again an r on the cone, and then we've got the multiplying of the two. Now there's also a different formula you could use as an alternate, and this basically applies to all types of frustrums, just like with the both, and you can remember this formula here, so which is a h over 3, and that's multiplied by the area of the top shape plus the area of the bottom shape plus the square root of the product of those two areas together. And like I said, it's entirely up to you which formula you want to use, as long as you remember one, and I would recommend that you stick to it. Now there wouldn't be in a situation where one will suit the other, because like I said, it's all involving algebra manipulation and moving things around and rearranging the formulas, etc. But personally speaking, when you're dealing with frustrums, it will usually involve working out the volume with so forth, and we can go from there. So in terms of another question I usually get asked is what are the most commonly asked questions relating to volume of complex shapes. So the first one is finding the volume as per, so that is where you are using the formulas as mentioned above, and I strongly recommend you make a note of those formulas. The second one is when you're working with spheres and cones, finding the volume in terms of pi. So this is where you won't necessarily need a calculator. The radiuses and the lengths will generally be nice numbers, and you can then use your pi to work it out. The third type is reverse question. So this is when you're given the volume and you're wanting to work out one of the lengths, so whether it be the height or one of the base lengths or one of the lengths involved. The fourth is volume questions leading to capacity. So this is where you work out the volume and then you need to relate it to capacity, and the key thing to remember there is that 1,000 centimeter cubed is the same as 1 litre. The fifth one is links to surface area, which will be covered in another video. The sixth one is comparing volumes. So again, a very typical question that comes up is when you're given two random shapes, 3D shapes I should say, and you need to write down which one's got a higher volume. So you could compare, let's say, the volume of a cylinder and the volume of a sphere, or you could also get questions, and I've seen this quite regularly, is questions where you've got a cylinder metal rod and it's been melted and it's been turned into a sphere, and you then need to work out the dimensions or the radius of the sphere that it could be melted into. And so questions like that. And like I said, I'll be doing another video going with examples of each of these 8 sort of things. The next one is compound volumes. There's a mixture of shapes joined together. So for example, now you might need to excuse my freehand drawing of this. So for example, you could have a shape that looks, so here what we've got is a cone a cylinder, and we've got a hemisphere. So where you might have to work out the total volume of a shape by linking the three sort of complex 3D shapes together. And then finally, the more higher level one that you could get asked is working out the volume of a frustum, so either a cone or on a pyramid. And you can also similarly, there is all strong links when working with frustums with similar shapes and volume, which again I will cover in another video. Now, one thing I would strongly recommend that you do is make some general notes and make a poster. Now, if you don't want to make your own poster, there are several things you can find on Google. So just Google image volumes of 3D shapes, and there's so many different posters you can have. But I definitely would have one in close by, particularly when you're revising or when you're dealing with these topics. Now, we'll do a video based on each of those 8 things you can see, where you can go through some examples of some of the typical questions you're likely to get asked in an exam or in a homework or in your class.